Alright, so polynomials and operation rules. The first thing we're going to need to know is some vocabulary. So what is a polynomial? It's an expression that has more than one or more terms, excuse me. So polynomials that have 1, 2, or 3 terms specifically have special names that are all their own. We'll get into that in a little bit. The degree of any term is the exponent of the variable in that term. Degree of the polynomial is the largest exponent of the whole polynomial. Standard form lines up the terms in order of degree going from largest to smallest. And the leading coefficient is the first coefficient of the polynomial that is in standard form. So an example of a polynomial that's in standard form, normally all you're going to see is just this black polynomial. But what you see all around it is everything labeled. So if we take a look over here, alright, all the exponents are circled. And even though that exponent wasn't there, I wrote in the 1 in orange because you don't normally write in the 1. Alright, those are the degrees of each term, okay? This whole thing is a polynomial. It's an expression with several terms. The exponents are in decreasing order, which makes the whole thing in standard form. Alright, 3 is the biggest degree of the whole polynomial, so it is the degree of the polynomial. And 4 is the very first number that's being multiplied times a variable when it's in standard form, so that's the leading coefficient. Alright, so I said polynomials have special names determined by how many terms it has. So if it has 1 term, it's a monomial, mono meaning 1. If it has 2 terms, it's a binomial. I think of a bicycle has 2 wheels. If it has 3 terms, it's a trinomial. Tricycles have 3 wheels. And if it has 4 or more terms, it's a polynomial, poly meaning many. Right, so polynomials also have names according to degree. So it can have, one polynomial can have 2 different names. It's going to have a name determined by the number of terms and a name determined by a degree. So polynomials by degree, if it's 0, meaning that there are no variables, okay, no variables whatsoever, the biggest variable is raised to the 0 power, meaning it's just not there, that's a constant, okay. If the largest degree of the polynomial is 1, meaning the biggest x value is just x, it's linear. If the biggest degree of the polynomial is a 2, meaning it's x squared is the biggest variable, then it's quadratic. And if the largest degree is 3, so that it's x to the 3rd power, it's a cubic. So examples, we need to identify the characteristics of each of the following. That's kind of what you'll be asked to do. You'll be given a polynomial. It'll ask you number of terms. There are 2 terms here. It'll ask you degree, and I scan my variables and I see that this is an x, that there's nothing up here, which means it's an understood 1, so the degree is 1. The leading coefficient, since it's in order from 1 to 0, if you will, there's x to the 0 power not written there. So the leading coefficient is -4. There are 2 terms, so it's a binomial. It has a degree of 1, so it's linear. So this is a linear binomial. If you look at our next example, I have all of these guys. There are 4 terms, 1, 2, 3, 4. I scan my exponents and I see that 3 is the largest exponent, so the polynomial has a degree of 3. They are not in order, but if they were, right, so that's our most important guy right there, he would be first. So my leading coefficient is 3. If this said -3, my leading coefficient would be -3. Alright, name by number of terms, it has 4 terms, so that's a polynomial. And name by degree, the degree was 3, making it a cubic. Alright, so besides just being able to identify polynomials, you're going to need to add them and subtract them and multiply them. So whenever you're adding polynomials, you're just combining like terms. So they'll be given to you in parentheses, but you can just ignore the fact that the parentheses exist, put your like terms together and just add. When you're subtracting polynomials, the first thing we got to do is get rid of the parentheses. But what you have to do is distribute the negative to every term in the second parentheses. Then after that, you're just combining like terms again. So in order to get rid of the parentheses, I leave the first set alone. I have my negative sign here, and I'm going to distribute that negative to each of the terms. So this one's currently positive, but it's going to be made negative. This one's currently negative, so it's going to be made positive. Then you just combine your like terms, so your answer is just going to be -5x squared plus 11x. Alright, so to multiply polynomials, When you're multiplying a monomial into any polynomial, that's just distribution. You've already done that a whole bunch of times before. You take what's outside of the parentheses and multiply it times every piece inside of the parentheses. When you are multiplying two polynomials together, it's still just distribution, but you have to distribute all of the terms of the first polynomial into the second polynomial. I knew I had the wording right when I wrote it. So you take the first polynomial and you take each one of those terms and distribute it to every term of the second polynomial. Then you combine like terms. So if we take a look at this, I'm going to take this first term, I'm going to distribute it to both terms and write those multiplications down. Then I'm done with him, and I take the 3 and I distribute it to both pieces and I write those terms down. So then I combine my like terms, x squared, there's no other x squareds. Negative 3x and positive 3x cancels out to 0, and negative 9 is right here, so it's just x squared minus 9. Alright, so I tried to color code it a little bit better for this first one. I take the 3x and I distribute it to both pieces. Right, so I actually should have written these two in opposite colors. So the 3x times 2x is 6x squared. 3x times negative 4 is negative 12x. Then I have got negative 1 times 2x is negative 2x. And negative 1 times 4 is 4. So I take the 3x and distribute it and come up with those two answers. And then I take the negative 1 and distribute it and come up with those two answers. So it is just 6x squared minus 14x plus 4. So the reason we have to do this is because we can use these to find areas and volumes of unknowns. So if I said find the area of this right here, then what that is area is length times width. So my length and my width are represented with polynomials or binomials specifically. Sorry about that. So I'm going to take my 7x plus 10 and my 4x plus 8 and multiply them together. So 7x times 4x is 28x squared, 7x times 8 is 56x. I'm done with that. Now on to my 10, and I got 40x and 80, and then I combine the 56 and the 40x, and that's 96x, and that's the answer. To find volume, however, I've got to multiply base times width times height, length times width times height. So I write all three of them together, and I'm going to multiply these two first because that's just easy distribution. That's x squared plus 3x. Now I'm going to multiply the two polynomials. So x squared times x squared times 6, 3x times x, and 3x times 6. So I combine my like terms right here, and I end up with 9x squared, x cubed plus 9x squared plus 18x.